All right, so we just finished up the evaluating logs, but I'm going to continue on our notes here. So if you guys would go back to your notes, and we're going to do something that is a little bit different. I'm going to give you 3 log rules. Okay, so these you should definitely write down. So first rule for logs is if you have a log, and I'm just going to put it base b because it could be any number, log base b of x plus log base b of y. If the 2 logs have the same base, so we have log base b of x plus log base b of y, we can condense it and write that as log base b of x times y. Okay, so if we condense it, the addition becomes multiplication if we condense it into a single log. And I'll give a lot of examples of these in just a minute. So there's an addition, that's the addition rule. There's a subtraction one. So if addition becomes multiplication, subtraction becomes division, right? So if I have log base b of x minus log base b of y, that's going to be log base b of x divided by y.
Wait, is the first problem all on the same line?
All on the same line, yes.
Okay, thank you.
Yep. Remember, the b's are subscripts, though. The b's, those are written smaller and a little bit lower. And same with the second one here, okay? So we have, for the second one, log base b of x minus log base b of y. If we're condensing it, the subtraction becomes division. And then our third rule, if we had something like y times log base b of x, this one's different. It's an exponent rule. That y becomes our exponent. So if it's written out front, we can write that as an exponent. So that would be log base b of x to the y power. So those are our 3 rules of logs that we're going to use to condense in our next couple examples. All right, I'm going to scroll up here. I hope I'm not moving too quickly, you guys. I know that's a lot to write down. So we're going to condense to a single log. Okay, here is our first example. Let's say we had 3 log base c of x plus 4 log base c of y. All right, I'm going to use the rules above, and I have to scroll down here to use them, but here's what's going to happen. The addition means we're going to make it into multiplication, and the coefficients are going to become exponents. So as a single log, this is written log base c of x to the third times y to the fourth. That is our one-step answer. So I'll give you a second to write down, then I'll explain again. But it becomes log base c of x to the third times y to the fourth. So we're condensing to a single log. The coefficients, always take those right away and make that your exponent. So that's where x to the third comes from. That's where y to the fourth comes from. And because it's addition, we make it multiplication.
Wait, so why did the numbers become like powers?
Yeah, that's the third rule of logs here, that if you have a number out front, you can make that an exponent of what you're putting into the log. Okay, so I'm applying that third rule there. All right, let me give you another example. All right, whoops, wrong mode here. 2 log base 7 of A minus 4 log base 7 of B. So we have 2 log base 7 of A minus 4 log base 7 of B. So the 2 is going to become an exponent there. The 4 is going to become an exponent there. And the subtraction is going to make this division. So when I write this as a single log, this would be log base 7 of A squared divided by B to the fourth. That is our answer as a single log. Log base 7 of A squared divided by B to the fourth.
Mr. O'Connor, I have a question.
Yes.
So you know how you put A over B?
Yeah.
Like would we get it wrong if we put the B first?
I'm sorry, I didn't hear that, Sadiqa. Say it again, please.
Would we get it wrong if we put B over A?
Yes, you would. Yeah, that's a really good question. The reason it's A over B is because it's this part minus this part. So that minus, this is where the division happens. And so that's why this has to go on top and this has to go on the bottom. Now, if you're multiplying, it doesn't matter because there is no top and bottom, but when you're dividing, it does. So good question. And again, so we did that 2 became an exponent, that 4 became an exponent, and we divided. So that's where the A squared divided by B to the fourth. All right, let's do another one here. Let's say we have, how about R log of X? So I didn't write a base. Remember, that means base 10. I don't have to write anything, but that assumes base 10. Minus Q log of Z. That is an ugly looking problem. We have R log X minus Q log Z. So minus means it's going to be like the last one, a division. That R is going to become an exponent. The Q is going to become an exponent. And so our answer as a single log would be common log of X to the R divided by Z to the Q. So that R became an exponent, that Q became an exponent, and it was division.